Hello, my name is Carlos Reynoso. I'm going to be presenting on the modular construction system, the advantages and implementation of a single wall system with integrated infrastructure. So, quick overview. This project proposes the one wall modular system, which integrates the essential infrastructure like power, water, sewer, and gas into a single prefabricated wall constructed from structural insulated panels. It emphasizes how the system enhances energy efficiency, reduces construction timelines and costs, and offers a scalable and sustainable alternative to traditional construction methods. So the research motivation for this project, the construction industry faces challenges related to extended project durations, high labor costs, and significant environmental impacts. This research investigates the potential of a single wall modular system, which integrates all critical utilities into a single prefabricated element to address these issues by enhancing construction efficiency, reducing costs, and minimizing the environmental footprint of building and construction. So the literature review that this project builds off of, one of the first literature review that was done was on the paper optimizing modularization of floor plans and modular construction projects by Alma Shakekbe and El Reyes. The paper presents an optimization model for modular construction projects that balances minimizing costs and maximizing floor plan functionality. It progresses through formulating variables, objectives, and constraints, implementing linear programming computations, and evaluating the model via a case study on an office building. The model's innovation lies in determining optimal room dimensions within modular units to efficiently manage costs while enhancing functional performance, providing planners with a tool to make data-driven decisions about floor plan design and resource allocation. This paper is particularly relevant for the one-wall system proposal as it explores an optimization model for modular construction, focusing on cost minimization and functional performance maximization, key aspects of the one-wall project. By analyzing optimal room dimensions and trade-offs between construction cost and floor plan functionality, this research provides insights into efficient modular design and resource utilization, which can be directly applied to the design and implementation of the one-wall system, ensuring it meets both economic and functional criteria effectively. The second paper that was studied for the literature review was Facility Layout Design for Modular Construction Manufacturing, a comparison based on simulation and optimization by Yang Z and Liu W. The paper Facility Layout Design for Modular Construction Manufacturing by Yang and Liu discusses the shift in modular construction manufacturing towards factory-based production, focusing on optimizing facility layout design through simulation and analysis. The study explores different layout designs, finding that the cellular layout maximizes output and the product layout is most cost-effective. The paper emphasizes the potential of Industry 4.0 technologies to enhance the modular construction process, suggesting further research to fully integrate these advancements into the construction industry. This paper's exploration of FLD in modular construction manufacturing is highly relevant to the development of the one-wall system. Understanding optimal facility layouts can directly influence the efficiency of producing modular components like the one-wall system. By adopting the best layout, such as the cellular layout, found to maximize output, production of the one-wall system can be optimized for efficiency and cost effectiveness. This aligns with the need for streamlined production processes in modular construction to meet both quality standards and production timelines. So in summary, the one-wall system builds on both of these research papers to establish a basis for producing a project like the one-wall system, utilizing enhanced, efficient facility analysis, as well as understanding how the system can be implemented into existing construction projects. So here's a overview of the one wall system and its variations. Primarily, the one wall system is broken up into a kitchen variation and a bath variation. Each system contains all of the critical infrastructure for either the kitchen or the bath to work as an isolated unit and be produced as such. So the conceptualization, here's a 3D view of the one wall modular system. As you can see, the layouts have all of the sewage, water line connections, all of the gas connections, as well as electrical conduit for outlets and appliance and fixture connections. So SIPS was chosen as the material to build the one-wall system. Structural insulated panels play a critical role in the one-wall system by enhancing its thermal efficiency and structural integrity. These panels, typically filled with a high-performance foam insulation, contribute significantly to energy conservation and reduce air infiltration, making the one-wall system exceptionally energy efficient. Here is an isolated view of just the systems that get integrated into the one wall system. Each of these would be produced independently and be designed on a per project basis. So during manufacturing, the one wall system's infrastructure comprising electrical, plumbing, and mechanical systems is meticulously integrated into the SIPs. This integration occurs in a controlled environment where the structural frame is first assembled, followed by the installation of infrastructure elements. So to demonstrate the flexibility of the single wall system, I've designed a couple examples which show its various applications. So the one wall system's application in a studio unit exemplifies its fundamental efficiency, integrating all essential services within a single wall to maximize the use of limited space. This model demonstrates how the system can effectively support smaller residential formats by simplifying construction processes and reducing material usage. The streamlined approach offers potential cost savings and faster completion times, ideal for urban settings where space and time are at a premium. So here's the example of the system utilized in a house. In a two-bedroom house, the one-wall system showcases its versatility and impact on reducing construction complexity and time. By centralizing critical infrastructure, the system facilitates quicker assembly and more straightforward site management, significantly enhancing residential construction efficiency. This example highlights the adaptability of the one-wall system to diverse housing needs, promoting sustainability and cost effectiveness in family-sized dwellings. So in this example, I placed the one-wall systems on the interior walls, independent of the exterior walls. This is a technique that could be implemented if the system were to go into production, where the exterior walls could be framed up independently and the one wall system could be installed during the framing process. So actually further speeding up the production schedule, as typically the exterior walls are the weight-bearing walls of single-family dwellings. This would be perfect for the one wall system to be implemented. And lastly, in the hotel wing example, the implementation of the one wall system in a 128 unit hotel wing illustrates its scalability and effectiveness in large scale commercial projects. Each unit benefits from the prefabricated wall, ensuring uniform quality and rapid assembly across multiple stories and sections. This scenario underscores the system's potential to revolutionize the hospitality and construction sector by minimizing disruptions and accelerating project timelines on a grand scale. As you can see in the example, all of the one wall system elements for the kitchen and bath are next to each other and stacked up on one another, reducing the plumbing runs and electrical runs required to accomplish a project like this, saving money and time in the long run. The construction efficiency analysis was conducted to really analyze if there was any construction schedule time savings by implementing the one wall system. So in this example, the traditional construction schedule for a typical two-bedroom, two-bath unit spans 26 days, involving sequential stages of framing, utility installations, and finishing. This extended timeline reflects the need for coordinating multiple trades and managing various on-site activities, often leading to inefficiencies and increased labor costs. In the single wall modular method example, utilizing the one wall system reduces the construction schedule to 23 days instead of 26 days by integrating essential utilities into prefabricated panels, allowing simultaneous progress in multiple construction phases. This streamlined approach not only speeds up the entire building process, but also minimizes the dependency on multiple subcontractors, leading to significant time and cost savings. So in this example, savings are seen not only on the installation portion of the kitchen and bath systems, but also on the back end, on the trim outs, where all of the trim locations are already pre-established and pre-coordinated during the design phase of the one wall system before it ever gets out to the site. This minimizes any potential issues or rework that often needs to happen on construction sites. So the efficiency analysis yielded a 11.5 schedule reduction, which is a significant schedule reduction considering the slight change was just introducing a pre-built portion of the building and not the entire building. So in conclusion, the one wall modular system exemplifies a significant advancement in construction technology by integrating essential infrastructures into a single prefabricated wall. This system, built using structural insulated panels, not only enhances energy efficiency, but also optimizes construction timelines and reduces labor costs. The economic, environmental, and operational benefits discussed underline its potential to streamline building processes across various sectors, including residential and hospitality, where repetitive designs are common. By offering a scalable, efficient, and sustainable alternative to traditional methods, the one wall system holds the promise of transforming the construction industry, advocating for broader adoption and continued innovation in modular construction techniques. That's my presentation. Thanks for listening. If this was a live presentation, I would take questions at this time. So I'll just bring up some questions that came up during my research. One of the questions that was presented was how significant would the savings be on a schedule basis for improving the efficiency of the trim out. So these factors were considered in the schedule savings from 26 days to 23 days, reducing the amount of time required for trim out from 3 days to about half the time, 1.5 days, where the locations of the various fixtures are already established and don't need to be calculated or figured by the installer. Another major question that came up was how would this system integrate into already existing and pre-established construction methods utilized in the construction industry today. The benefit of the system is that it utilizes all the same technologies and construction methods of traditional construction. It just offsites some of the more sort of complicated and time-intensive portions of the construction process, which are typically the kitchens and the baths. So the rooms, they themselves, the actual build out of them on the construction site are pretty standard. The locations of the outlets are predetermined by energy codes, electrical codes. The locations of plumbing fixtures are also pre-established, but this can all be done off-site with the kitchen and bath one-wall systems. So the system could already be integrated into probably a lot of existing construction projects in the pipeline and could easily integrate into a lot of the designs with probably some minor changes, utilizing some of the studies in the literature review that would optimize the floor plan layout a little bit, and then probably need to be further optimized to accept the one wall system. This would be a study, of course, that could be done on a per project basis to analyze the feasibility for a project to accept a system like this. But yeah, if any other questions come up, please feel free to send them my way. Lastly, here are my references for this paper. A more expanded version of this is on the paper itself. Thank you.